Okay, this seems to be working fine. So let's have a look at question 5. Again, I'd pause it, have a go, and then come back to me in a second. So I've got a box with sides x, x plus 3 and 2x. I think this calls for a terrible but quick sketch. So I've got x, x plus 3 and 2x. So write down an expression for the volume of the box. Now it just says write down an expression, so I'm not even going to tidy it up. So it's going to be that times that times that. That's an expression for the volume of the box. You might be shooting yourself in the foot by not tidying it up, and in fact I can't quite help myself. I am going to do that, but that's how I'm going to leave it. So that's the volume. Right, and then it tells us that the volume of the box is 980. So this is my volume, and I'm told that that equals 980. So now I need to tidy this up and get a quadratic. Oh, sorry, it's a cubic. I'm going to get a cubic, which hopefully resembles the one in the book. But anyway, we'll just fiddle with it and then see what we get. I'm going to divide both sides by 2 to begin with. So I'm going to get x squared, x plus 3 equals 490. You might not have done that. You might have weighted, expanded, and then divided through by 2 at the end. That would have been fine. So I get x cubed plus 3x squared equals 490. So I get x cubed plus 3x squared minus 490 equals 0, which is what they want. So that's rather good. Right, now we need to show that x equals 7 is a solution to this equation. So what I'm going to say is I'm going to name this cubic as f of x. So I'm going to say that this cubic is f of x. Like, oh, you haven't got a clue what I'm doing. Like this, so f of x, like that. We know that if f of a equals 0, then x minus a is a factor. Do you remember that from the factor theorem? If you don't, have a look at the factor theorem. So we've got, if f of a equals 0, then x minus a is a factor, and x equals a is a solution. That's a very posh way of saying, if I do f of 7 and get 0, then 7 is a solution to the equation. So f of 7 is 7 cubed plus 3 times 7 squared minus 490, which is 343 plus 147 minus 490, which is 490 minus 490, which is 0. So f of 0, f of 7 is 0, hence x minus 7 is a factor of f of x, and x equals 7 is a solution to f of x equals 0. I'm going to add that up here as well, is a solution to f of x equals 0. That kind of goes from the remainder theorem as well, doesn't it? If you put in a number and you get 0, that means the remainder is 0, and hence that factor fits perfectly and must then be a solution. Prove that the equation has no other real solutions. Right. So, what have I got? Let's go back to what I know. I know this, and I know that x minus 7 is a factor. That's what I've just discovered from the previous bit. I think I'm going to do some polynomial division, and I think I'm going to turn over to do it. So, what was it? Somebody remind me? Ha ha ha, funny joke. Right, x cubed plus 3x squared minus 490, and we know that x minus 7 is a factor. Right, let me just check. X cubed plus 3x squared minus 490. Okay, right, I'm going to do my polynomial division then. So, because I know this is a factor, I can divide by it. That will hopefully leave me with a quadratic, which hopefully won't have any solutions, so that I can say there's no other real solutions. So I'm dividing x cubed, 3x squared. Now I'm going to put 0x, because I know that in a second, if I don't put 0x, I'm going to be really stuck. And I'm dividing it by x minus 7. So, how many x is going to x cubed? So I do x times x squared minus 7 times x squared, and then I take these away. X cubed minus, cubed, x times x squared is x cubed. X cubed minus x cubed is 0. 3x squared minus 7x squared is 10x squared. And then I bring down these other terms that I haven't dealt with yet. Right. How many x's in 10x squared? Well, that's 10x. So I've got x times 10x is 10x squared. Minus 7 times 10x is minus 70x. So 10x squared minus 10x squared goes 0x minus 70x is 70x. Then I've got minus 490, which I'm going to bring down. Then how many x is in 70x? Well, that's 70. So I've got x times 70, and I've got minus 7 times 70. 70 to take away 70 is 0. Minus 490 minus 490 is 0. We knew that was going to be 0 because we said that it was a factor. If that hadn't turned out to be 0, we would have had a problem. So f of x is x minus 7 x squared plus 10x plus 70. Right, so this is one solution. The question says to show that it's got no other real solutions. So our job is to show that this part doesn't have any other real solutions. So let's try and solve x squared plus 10x plus 70 equals 0. Right, let's solve that and see what we get. I'm going to do the quadratic formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Right, I'm going to, in fact, just look at 100 minus 4 times 70, because that is less than 0, hence the square root of that has no real solutions. Okay, so I've done the quadratic formula. The bit in the square root turns out to be negative, and hence it's got no real solutions. So the only solution to f of x equals 0 is x equals 7. That's probably what I would write, something like that, just to round it off. Super. Right, question 6. More paper, I think, is called for. Right, question 6. What have we got? We've got an f of x being x cubed minus 5x squared minus 2 plus 1 over x squared. That is, believe it or not, a 2. Oh, look at the state of that. Right, x cubed minus 5x squared minus 2 plus 1 over x squared. The point P with x coordinate minus 1 lies on the curve. Find the equation of the normal to the curve at the point P. Right. Well, I think we should start by finding this y value, because we're probably going to need it. So let's stick minus 1 into here and see what we get. I'm going to do that by putting minus 1 in carefully with brackets. Right, I get minus 7. With any luck, that's right. We'll find out. Okay, so what else do I need? Well, I want the equation of the normal to the curve. So, I got that by sub in minus 1 to f of x. x. That's how I got that number. Right. I need the normal. So I know I'm hoping for a y equals mx plus c. So I need an m. Now we know that m is gradient, and we know that we find the gradient by differentiating. So I'm going to rewrite my f of x. I'm not differentiating now. I'm rewriting it in a differentiable way. So instead of 1 over x squared, I'm going to write that as x to the minus 2. Right, now remember, when we differentiate, we write f dashed. So now I'm going to differentiate this. So I've got 3x squared minus 10x. So multiplied by the power, reduce the power. Multiplied by the power, reduce the power. That's just going to go multiplied by the power, reduce the power. Right, so that's the expression. Now I want the normal at p. So I'm going to do f dashed of minus 1. So that's going to be 3 times minus 1 squared minus 10 times minus 1, like that. So I'm going to put that in and see what I get. I get 15. Right, so the gradient of the function at the point minus 1 is 15. Now I want the normal. So remember, for a normal, we're looking for something that's perpendicular. Okay? So remember what is true if we want to find a perpendicular gradient. We flip the gradient upside down and we give it a minus sign. We find what we call the negative reciprocal. So the gradient of the normal, I'm going to flip that upside down and I'm going to give it a minus sign. Okay? Right, now I'm going to use, I've got my point, I've got my gradient, so I'm going to use y minus y1 equals mx minus x1. Now you could at this point use y equals mx plus c and find c. That will also work. But I'm going to use this, and my point is minus 1 minus 7, I think. So y minus minus 7 equals m x minus minus 1. So I get 15y plus 105 equals minus x minus 1. If I multiply up by the 15 and then do minus 1 times x minus 1 times 1, so I get 15y plus x plus 106 equals 0. It's going to be pretty amusing when I check this now and this turns out to be incorrect. X plus 15y plus 106 equals 0. No, that's good. We have got it. That is exactly what we should have. So we did that by realising that because it wanted the normal, we needed to know the gradient. To work out the gradient, we knew we needed to differentiate. To differentiate, we knew we needed to write it in a nice way. Okay? At this point, you could have used y equals mx plus c. That would have been a perfectly fine way of doing that. Right. Question 7. The population of a colony of endangered Caledonian owlet nightjars. I mean, why they've picked that, why they haven't just done giraffes, I've got no idea. So the population of a colony of giraffes can be modelled by the equation P equals AB to the T, where A and B are constants and T is the time in months since the first population was recorded. Wow, what a load of waffle. So the line L shown in figure 2 shows the relationship between T and log to base 10 of P for the population over 20 years. Write down an equation of line L. Right, we want an equation of line L. So, let's see what we've got. Line L goes through the point 0, 2 and 22.2. They're the points that line L goes through. So we need an M and we need a C. C we know, C is 2. That's where it crosses the y-axis. So we need an M. So we do y2 minus y1, x2 minus x1. Yeah, difference in y divided by difference in x. So 2.2 minus 2 over 20 minus 0, which is 0.2 over 20. which is probably something 0.01. I think, divide it by 2 and then divide it by 10. Yeah, 0.01. So I get y equals, well, either 1 over 100 or 0.01 x plus c. Now, the c just comes from where the picture crosses the y-axis. Now, we just need to remember that we're not in the y equals mx plus c world. Our y is log to base 10 of p, and our x is t. Okay, so don't forget to put your answer in terms of the letters that we're dealing with in the question. Okay, so we haven't got any x's and y's. Our y, if you look on the axis, it's labelled as log to base 10 of p, and our x-axis is labelled as t. So that's the answer to part A. Right, now it says work out the value of A. So A, remember, comes from this formula here. So I've got P equals AB to the power T. And now I need to work out the value of A. So if you look at this and this, we are somehow going to have to equate these. So let's take log of both sides here. So I'm going to take log to base 10 of P. That's looking good. And I'm going to take log to base 10 of AB to the power T. Now, hopefully you remember the rule that log of A times B is log of A plus log of B. That's a rule that hopefully you've come across. So that means this side is still this. That means that on this side I've got log to the base 10 of A plus log to the base 10 of B to the T. Now, hopefully you've got another rule up your sleeve here, that if you've got log of x to the power A, that's A times log x. A power can be brought out the front. So I've got log to base 10 of A plus, that t is going to come out the front like that. Okay? Right, now what are we doing? What's the question? We want the value of A, and then we need to interpret it. So to start with, we need to work out the value of A. Right, well, if you look, A comes from this bit, which is just a constant number. So I can equate this bit with my constant number here. So I get log to the base 10 of A equals 2. Okay? I've done that because if you look, this line and this line are the same thing. My 0.01t must be this bit because that's where my t is. And then my number must also be the same. Okay? So, log to the base 10 of A equals 2. So that means what number do I get when I raise 10 to the power of 2, which gives me 100? Yeah, so what number, the number that I put in there, so for logs, I always write that log to base 2 of 8 is 3. So the power, so this is like my little fact that I always use, and I write that on every question. So that means what power do I have to raise 2 by to get 8? So this is saying, what number do I have to raise 10 by to get A? I have to raise 10 by 2 to get A. In other words, in order to get rid of the power, you do 10 to the, in order to get rid of the log, you do 10 to the power of that number. So here, that is true. If I had £1 for every time I'd written that on a maths exam in my life, I'd be rich. So, if I do 10 to the power of this side, I just get A, and I do 10 to the power of this side, which gives me 100. So this tells me that A is 100, but it wants me to interpret this value in the context of the model. So that means kind of what is this value doing in terms of the population of giraffes or owl nightjars or whatever we've got. So if you look and think about what it means, this number is where the line crossed the y-axis. It was our initial number in our model. Hence this, now we've kind of taken our model and we've gone back to real life. This must be the initial population. So this must be how many owl things there were at the start. Okay, so there must have been 100 at the start. Our line crossed at 2. So there weren't 2 at the start. 2 was the number that we've got in this logarithmic model. At the start, there must have been 100. Now, if you look, initially, t will be 0, and anything to the power 0 is 1. So when t equals 0, I get that p equals a. So that's another way of thinking about the fact that this number relates to my initial population. Right, any guesses for working out the next part of this question? Work out the value of b. So if we look, we've got that 0.01 is the t coefficient. So I've got that log to base 10 of b equals 0.01. So I raise both sides. I put 10 to the power of both sides. So 10 to the power of that is just b, and I've got 10 to the power of that, which actually is going to give me the 100th root of 10, which I don't happen to know. It's 1.023. If you type it in, you get 1.023. And what does it want? 3 decimal places. Happy days. Good. And then part D. Hopefully it's a nice end. Part D. Find the population when t equals 30. Right, so what is the population now? It was a, b to the power t. That was our population model. And we know that it's 100 times 1.023 to the power t. I've put my a and b into this model, and we've got that t equals 30. So I'll type this in, and with any luck, now I'll show you what my calculator looks like now. My calculator looks, oh, you can't see that. My calculator looks like that. I've used the answer to give me the value. I haven't typed in the number. And then find the population predicted. Well, it's 199.5. Half an owl that seems a bit sad. Now, the answers would allow either rounding up or rounding down. I'll follow the normal maths rules and I'll round up. But they would allow rounding up or rounding down. Some people will round up because of maths, and some people will round down because if you've got kind of half an animal, you've got to round down because you haven't actually got that many animals. If the question doesn't specifically say, and it isn't kind of obvious, do either. So I think the 2 obvious answers are either 200 or 199. I don't think either of those is more correct than the other. I think either of those is probably fine. Right, I'm going to stop there. So what's that? That's the end of question 7. And I'll start a new video which commences at question 8.